مركز التعلم الذاتي، ريادتك للتعلم. جامعة السلطان قابوس.
Okay, last time in the last class we have taken, some of the fundamentals of forecasting, and we have taken a problem on applying some of the forecast accuracy methods. Like we have used a problem to calculate MAD, mean absolute deviation, and mean square error, and MAPI, mean absolute percent error. Today we will be applying some of the forecast methods, actual methods, into a problem. Okay, so here's the problem. We will solve the problem. Actually, we have about 4 forecast methods. We have the basic one, which is the naive, and we have the moving average, and we have the weighted moving average, and we have the exponential smoothing. So as you can see, this problem lists all of them. We'll be calculating naive and the moving average, and also there's the weighted moving average, and there's also the exponential smoothing. So let's solve the problem. I'll give you the formulas when we solve the problem, okay? But before, let's write down, the actual data. Okay. We have the week. Okay. 1, 2, 3, 4, 5, 6. Okay. And we have the sales. 105, 90, yes, 95, 110, 105, and 100. Okay. So first, let's calculate naive. Naive as a forecasting method, it is the basic one. Simply naive, it means, to make a forecast, you use a naive. The forecast for any given period is actually equal to the actual of the last period, which is written as, as a formula, Ft is equal to AT minus 1. And based on this one, if you are trying to make the forecast, let's say for period 3, F3, then actual, then the forecast will be the actual of 3 minus 1, which is actual of period 2. So let's apply this one. As you can see in here, it is not possible to find the forecast for the first period, okay? Because you will need to have the actual of the previous one, and we don't have it. So the first basic forecast that we can find is what? For period 2, which is equal, based on this one, is what? F2 is equal to 105, okay? And then for the second one, it is the previous one. Yes, 90, 95, 110, 105. And for period 7, since he's saying it here, produce all possible naive forecast, all possible. He didn't define it by a given period, so it is also possible to find the forecast for period 7 based on this one. So the forecast is what? Is 100. Okay. Now, what's the other one? Produce all possible 3-period moving average forecast, 3-period moving average. So that's a 3-period moving average. Okay, we can just call it MA, 3-period MA. Okay. A 3-period moving average, or the moving average, is simply just an average. We know the average is the total of the numbers of given numbers divided by the number of these, in the numerators, the normal average. But the difference is that, we call it a moving average, okay? And there's a reason for it that we will talk about later on after we solve the problem. But now the focus is only on applying the formula. So what is the formula for the moving average? Simply, the forecast for a given, period, okay, is equal to the summation of the actual of the previous periods for the number of periods. So if you are talking about, n equal to 3, then you need to take t minus 1 plus t minus 2 plus t minus 3 for the previous ones. Okay, from n equal to 1, from t equal to 1 to n to n to t equal to n to t equal to n. That's divided by n. Okay, we can easily compute it, just a normal average. Since we have a 3-period moving average, then to find the first average, we need how many numbers? We need 3 numbers, isn't it? A 3-period. We need to divide by 3. Therefore, we will be taking for the first week, second week, and third week, and therefore the first forecast that we can find is actually for period 4. And based on this one, F4 will equal to F4 is equal to 105 plus 90 plus 95, that is divided by 3. That equals to 209 divided by 3, 96.67. Okay, so based on this one, what is the forecast for period 5? It is 2, it's 90 plus 95 plus 110. Okay, 90 plus 95 plus 110 divided by 3. Again, that will equals to 98.33. 98.33. If you noticed, you will find out, you see that 105 was taken out. In finding the forecast for period 5, period 1 wasn't there because that's why what we call it moving, okay? Because n is fixed, it's only 3. You're only allowed to take 3 previous periods, starting from the most recent period. So if you are trying to find the forecast for period 5, then the most recent periods are actually period 4, period 3, and period 2. Period 1 will be out because you are only allowed to take 3 periods. But if n, you are taking a 4 period moving average, then of course you will be able to include period 1, okay? So what is the forecast for period 6 based on this one? We don't need to write all of this. 103.33. And what is the forecast for period 7 that we can find, isn't it? $100 plus 105 plus 105. Okay. 105. Good. Is that all clear? Okay. Okay. We need some space. Okay. So let me just omit those ones. Do we have some space in here? Okay. Let me just write the final numbers. Okay. So this one is 96.67 and this one is 98.33. So now we don't need this. Okay. Then in C it says find the forecast for week 5 given that weights of 0.33, 0.17 and 0.5 are used. So he only needs the forecast for week 5, okay? But it is using the same logic. But this one is what he's not identifying in here. He should be saying, this is, since he's giving the weights, then he's talking about weighted moving average. That's weighted moving average. The formula for the weighted moving average, the forecast for the weighted moving average is very similar to the moving average, except now that we have relaxed the weights. In the moving average, the weights is equal to 1 over n. Okay, so if you have a 3-period moving average, then the weight in the moving average is equal to 1 over 3, 1 over 3, 1 over 3. But in the weighted moving average, the weights are relaxed. Relaxed, it means that you can change the weights by yourself. So as you can see, they are given in here, but the formula for it is simply the summation of the multiplication of WT minus 1 by AT minus 1, okay, for all periods, okay. So if you have 3 periods, then the same thing. You'll be saying like, WT minus 2 multiplied by AT minus 2 plus WT minus 3 multiplied by AT minus 3, okay, which is, we are given 3 weights in here. For each period there is 1 weight, therefore we're talking about a 3-period weighted moving average. 3-period weighted moving average, okay. So it is simply you need to multiply the weight by the 80, okay. Now we can easily apply this one. If he asks, for example, in C to find or to produce all possible weighted moving average forecast, then what would be the first forecast, given that we are given 3 weights? What would be the first forecast that we can find? It is for week 4. It is very similar to the moving average, the 3-period. Therefore, we can find the forecast for week 4, week 5, week 6, and week 7. But in this problem, he's only asking to find the forecast only for week 5, So only one forecast. So based on this one, F5 will be simply the multiplication of the weights by the previous periods. But we should watch in here. As you can see, the weights are given as 0.33, 0.17, and 0.5. They are not in a descending order. They should be, ranked in a descending order, starting from the highest to the lowest. Where the highest weight will go for the most recent period, the second highest will go for the second, in the rank, and the third will go for the third in the rank. So let's apply this one for F5. 110 will be multiplied by which weight? 0.5. Very good, excellent. 0.5 multiplied by 110 plus 95 will be multiplied by which weight? 0.33, isn't it? 95 plus the last one, which is 0.17, is multiplied by 90. We should always make sure that the total of the weights is equal to 1. Then it is possible, like for example, if I ask for a 3-period weighted moving average, I can omit one of those ones and you can find the other one. Okay. For example, if I give you 0.33 and 0.17 and I take out the 0.5, then you should be able to find out that one if I tell you that there are 3 periods, because the total of this has to be 1. So what is the product of this? 65. Okay. So that's the forecast for period 5. You can find for 6, you can find for 7, and also you can find for 4 using the same approach. Always the weights will go for the most recent period. Okay, and the most recent period they change based on the forecast. For example, in period 6, what will be the most recent period to the week 6? Which period? It's going to be period 5. That you will multiply by the highest weight. Then 4 you will multiply by the second highest, and 3rd you will multiply by the least highest of them. Okay, the lowest weight. Okay, so we will need a space. We don't have so much space in here. Since we already have calculated naive and the 3 period, we will omit these two. And we will calculate, the last term, which is exponential smoothing. Exponential smoothing, ES, with alpha equal to 0.2. Produce exponential smoothing forecast for the series using a smoothing constant of 0.2, given that the forecast of week 3 is 98. Okay. Exponential smoothing is also classified as an averaging technique, similar to the weighted moving average, similar to the moving average. Okay. Therefore it is around average. We'll be discussing this one after we finish the problem. For the exponential smoothing, what is the formula for it? The formula will explain where to use each one of those givens, the 0.2 and the 98 in the question. Ft exponential smoothing equals to Ft minus 1 plus alpha multiplied by the difference between At minus 1 minus Ft minus 1. Okay. So Ft is equal to the previous forecast for the previous period, most recent period, plus alpha, which is a smoothing constant, multiplied by the difference between the actual of the previous period minus the forecast of the previous period. So actually this difference is actually the error. So what we are just taking is the proportion, a proportion of the error, and we are adding it to the previous forecast. Exponential smoothing is different from moving average, and although all of them are classified as averaging techniques, but exponential smoothing is a bit from a different family, okay, more advanced family for forecasting. As you can see in here, forecasting, to find a forecast you will need to make use of the previous forecast. But in moving average and in weighted moving average, there was no mention to the previous forecast in the calculation of the new forecast. Only the previous actual there was. Okay. So based on this one, produce exponential smoothing forecast for this using a smoothing constant of 0.2, given that the forecast for week 3. So week 3 is equal to, the forecast for it is what? 98. So based on this one, can we find the forecast for week 4? Yes. It is the previous, for week 4, it is forecast for week 3, which is 98, plus the alpha, which is 0.2, multiplied by the difference between the two. Remember, this is just a normal difference. This is not an absolute difference, just a normal difference. Therefore, it could be minus, it could be positive. So this is multiplied by the difference between the actual, which is 95, minus 98, and this one will equal to 97.4. Now the second one is with also 97, the previous one 97.4 now. Okay, the initial one, the previous forecast, the plus 0.2 multiplied by the actual, which is 110 this time, minus 97.4. Let's take this one off, so we have more space. 99.92. Okay, for period 6, it equals to the forecast for period 5, which is the product of the previous formula, 99.92 plus 0.2 multiplied by 105 minus 99.92. That will equals to 100.936. Okay, 100.936, as you can see. Okay, so for the week 7, we can find the forecast. You see, this one doesn't have an actual, but you can find the forecast for it, of course. That's the main aim of the forecasting, is to be able to find forecast for period in which you don't have an actual. Okay, so this one will equal to the previous forecast, which is 100.936 plus 0.2 multiplied by the actual, which is 100, minus 100.936. That equals to how much? 118.74. 118.74. Okay. Now we can easily select any of the accuracy methods, MAD, MSE, or MAPI, and you can apply them. And you apply them to each of the forecasting methods, and then you can find out which one of the forecasting method has performed the best. 100? 100.74. Okay. 100.74. Good, excellent. Okay. Is it all clear? Okay. Now you will need to solve more problems and to practice. Okay. You have some practice problems in Moodle, which we can solve and download and solve. So now we'll go back to the PowerPoint, and we'll try to cover some other points with regards to the performance of the different forecasting methods. Okay, some of the strengths and weaknesses of the different forecasting methods. Do you have any question from here? No. Okay. And let's go back to our presentation. Last time we have stopped at this one, isn't it? Trend, seasonality, cycles, irregular variation, and random variation. Okay. As we have said last time, you know, time series methods, they depend on the knowledge that you have from the historical data. The more the historical data that you have, the most likely your forecast for the future will be better. And therefore, you know, if you have a good amount of historical data, then it will be, you know, not correct not to make use of that historical data. Therefore, a first step would be to understand your historical data. What patterns are there into your historical data? Is there like a trend? Is there like seasonality? What type of data do you have? You need to understand your data precisely, because your data has everything that you need to make the forecast for the future. Okay, and based on this one, there are several behaviors or patterns of the data. There's the trend, there's the seasonality, there's the cycle, there's of course there's something called irregular variation and random variation. let's look at these ones. The first one refers to a trend. As you can see, there's an upward trend or an increasing trend. Okay, as you can see, over time the numbers they keep on increasing, but we have some point in there which is, we would call it irregular variation. The word irregular variation is very simple. A similar one is very similar, to what we call it in statistics an outlier. Have you taken outlier in statistics? An outlier is a number that is totally different from the other numbers. For example, if you have numbers like 90, 98, 95, 80, 85, suddenly you would have a number like 500. Okay, which is different than the other numbers. That number could be classified as an outlier. There's something similar in here. Irregular variation, a variation that is not similar to the other variation. There's a sudden increase, 1 point that is totally different, or a point that is lower, much lower than the previous one. What does that mean? It could be because of something that is not repetitive, that doesn't repeat itself. It might be of something that is not significant, and therefore to make a forecast, then it is better to remove that data out, so that you have a clear pattern, a clear demand pattern. But again, you will need to watch for that data. What was the reason for that irregular variation? It could be as a result of a customer who from time to time they approach your company and they buy from you in large quantities, and therefore you will need to find out if that's a repetitive one. It occurs for, let's say, every 6 months. You have that irregular variation. Every 6 months you have that sudden increase, and then it goes back to this customer. So then this customer could be an important customer because they buy large quantities from your product. Therefore, they could actually be regular, and therefore you need to plan for them very well. Okay, when they will come back, maybe after 6 months. So your understanding of your previous data and the reasons for the variations in your data is important to be able to make a good forecast for the future. Another one, let's take this one, the seasonal variation, from the word seasonality, okay, and seasons, okay. As you can see in here, we have months, okay, and in which we have, and these are the years. As you can see, this variation, for example, it repeats itself every time at around the same time: January, February, March, April. So around April, we have about the same pattern. There's an increase and then it goes back, and again. Around, what is that one? October. Okay, the same pattern. The seasonality is a variation that occurs within 1 year. Okay, it is within 1 year. It doesn't take mostly than a year, but that's why it's called a season. We could have several seasons in a year. Can you identify some of the seasons in a year? We have the summer season in Oman. Okay, we have the winter season. What other seasons that are famous in Oman, for example? Kharif Salala season. What's that one? Famous season. Kharif, Ramadan season. The 2 Eid season, Eid al-Fitr and Eid al-Adha seasons. These are all seasons, and therefore you will need to plan for them very well. But different products for different seasons. In Ramadan there is more demand maybe for Vimto, okay. But in summer there is more demand maybe for let's say other products, maybe ice cream or for other ones. In Eid, there is more demand maybe for other items that are maybe related to Eid, either Eid al-Fitr or Eid, al-Adha. And therefore, if you are able to identify a season in your data, then you will need to plan very well for that season. But sometimes a season is not identified easily. You could have a season that without any, indication. It is not summer, it's not, something that you can find or identify. Just in a given month, it's not an Eid or a Ramadan, but still, you have noticed from your previous data, when you watch your data for several years, you have found that 1 month the demand goes up. Therefore, you will need to find out what that, the reason for that one. It could be a season for you, and therefore you need to plan for it. This cycle is very similar to the seasonality. As you can see, there's a decrease and decrease, increases and decreases. But the cycle is larger in scope. It takes more like one cycle could take a whole year, just one cycle, one round, or it could take several years. Like the recession, okay, Rakud, sorry, and those ones, they take years, okay. Some people they say now the change in the fuel prices. Now what's happening now is not that this is not the first time. It has happened before. And it took, like, for example, it could take more than a year, and then it goes back, it could go back down or up, whatever. So this could be like, a cycle, and which also you need to plan for. But as you can see, the level of data, the depth of data, the historical of data, that you need to identify the cycle is not similar to the one that you need to identify the seasonality. In here you need maybe around 10 years or more to be able to to spot like 2 or 3 cycles, because each cycle could take 2 years. So if one cycle takes 2 years, how many years do you need? Around 6 years or 8 years to be able to see a repetitive, and then you can tell exactly, yes, this is a cycle. It is not just one time increase. Okay, because a cycle or a seasonality or a trend, they have to repeat themselves every time. If they only repeat them once, then they cannot call them like a cycle or whatever. Okay, a normal cycle. Okay. Now the forecasting methods, we have the naive that we have just solved the problem of, okay, which is simply using a single previous value of a time series as the basis of the forecast. As we have said, sometimes they call it the naive is equal to the last period demand or the actual, okay, which can be used with a stable time series, or it could be used with a seasonal variation, or it could be with the trend. And therefore, naive is a flexible one. But the problem with the naive is that, you know, to make a forecast of the naive, you only need one last period, okay, and therefore it doesn't make use of the of the whole period, of your whole pattern. It just makes use of just one number, okay, and therefore you could have, for example, you are at the bottom. Let's say, for example, you could be at the bottom of your seasonality, okay. Okay, and you are trying to make a forecast for this period. Okay, forecast for this period. Then naive will give you this one, isn't it? F t will equal to the actual of t minus 1. Of t minus 1. But is that a true one? Because you can see that, the demand for here, the most likely will go up, but the forecast will be less. So it could be a problem. Okay. But because it's, it uses only one point, therefore you can, it will be a bit flexible, but not that much. Let's look at, another one. The averaging methods, we have 3 types of averaging methods. We have the moving average, we have the weighted moving average, and we have the exponential smoothing. These are called averaging methods because they only use some type of averaging. You can see in here, moving average, weighted moving average, and exponential smoothing is also an average because you have the you have the smoothing constant, which is 0.2 between 0 and 1. 0.2 and the rest, which is 0.8, is hidden, but it is somewhere also in the forecast. Therefore, that's an average. In fact, there is another formula in which it has alpha and the other part of the formula 1 minus alpha. So you can see that it is an average. But we are given in the book a different formula. Okay. Average techniques, they can handle step change or gradual change in the level of a series, but they also have a problem. Each one of those ones, they have all of them. They have problems. Some inherent problems. This is the moving average. That's just the formula. Okay, we have talked about the formula. Let's talk about some of the issues with regards to the moving average. As a new data become available, the forecast is updated by adding the newest value and dropping the oldest one, and then recomputing the average. The number of data points included in the average determines the model's sensitivity. Fewer data points used, more responsive. More data points used, less responsive. Moving average, the good thing about it is that it gets rid of the old data, and it updates itself every time with the newer data, which is quite good. If you have a trend or seasonality, then it will be able to capture with the new things that happens into your data. But it differs in the selection of the n. Okay, in the denominator, the 3-period, for example, moving average is different from a 4-period moving average, is different from a 2-period moving average, is different from a 5, 6, or 10, or whatever number of periods. Why? What difference does it make? When you decrease the number of points, the number of periods, like for example from 5 to 4 to 3 to 2, your forecast will be more responsive. Okay, and when you increase n, your forecast will be less responsive. What does more responsive and less responsive mean? Simply, an indication of this one. Of course, the only way to understand this fully is to take 2 problems. One with n, for example, equal to 6, and one with n equal to, for example, 3, and you calculate the 2 and you see the differences. But I'll tell you how does it look like. For example, let's assume that you have this data, this type of data in which there is a fluctuation on it. Okay, with the n, let's just assume with n we have n equal to 3 moving average and n equal to 5 moving average. Okay, according to what says in here, and the application of the data on moving average, application of moving average on the data, when you take n equal to 5, the forecast will look something like this one. Variation is gone. You see, there was a variation in here. This variation is almost gone. It's just like you have like a straight line. With n equal to 3, you will have a bit more variation. Okay, so when you increase n, you will get closer to a straight line. When you decrease n, you will be getting closer to this type of fluctuation. But still, part of your fluctuation will be killed because it is still, it's called an averaging, normal averaging technique. It will kill the variation. Averaging, when you take the average of 3 numbers, it will give the middle number, and therefore the middle number will kill this fluctuation in your data. You can apply it to different problems. Now the point behind this one, this is more responsive compared to this one. This is less responsive. Now what does that mean? Are you interested in this fluctuation in your data? Do you think this fluctuation is important to your data? If you think it is an important fluctuation to your data, then maybe you should select a small n. But if you think that this variation into your data is like a random variation, what we call it as a noise, or it is not important, then, and it's just a noise that doesn't add value to your data, then there is no harm to go for like a larger value of n where you can kill this variation because it is not important to your data, and you can obtain this one. But if it is an important one, like a type of a seasonality or something, maybe you want to use a small n. You got the difference between the two? A small n will capture the variation. Large n will most likely kill so much of the variation. So it depends on whether you want to capture the variation or not. But still, that is all within limits of what we call it the characteristics of the averaging techniques. You cannot go beyond their limits. The weighted moving average, okay, as we have talked about, in the weighted moving average, the weights are relaxed, which means that you can select yourself. But you need to make sure that the total of the weights is equal to 1. You select the 3 periods first. For example, let's say 3 periods. Then you have 3 weights. Make sure the weights that you select, the total of them will equal to 1. Because if they do not equal to 1, mathematically that's not right. That's not an average. Okay. For example, if we have 3 periods and you have selected 1.7, then you could select the other one 0.2 and the last one 0.1. Therefore, 0.7 plus 0.2 plus 0.1, that will equal to 1. Okay. What's the difference between the weighted moving average and the moving average? In the weighted moving average, because you are given the selection of the weights, therefore, if you think there is more value onto the most recent period, the period that is very close to your forecast, if you think that most of the knowledge that you need about future demand is available in your most recent period, let's say you want to make a forecast for period 5, and you believe that period 4 will be very similar to period 5, okay, then you could either go maybe for naive, it will give you a very similar, or for example, if you want to use weighted moving average, you could give the highest weight, so much like 0.9 to the most recent period, and very small weights, 0.05, 0.05 to the other previous periods. By this way, most of your forecast will be captured from the most recent period. Okay, but still that also again, like you also to remember as well that you are talking only within the limits of the averaging techniques. Okay, when you will still, for example, whatsoever, let's say you have like okay. If you take like 3 numbers in here and you want to make a forecast for this period, just a simple example. Okay, according to the moving average, let's take the moving average first. The moving average, you will take the average of these 3. Okay, if just the distance between each and the other one is equal, then most likely the average will be, isn't it, this one, isn't it? But is that representation of this one? No, the new one, the new data, there's a decreasing pattern is there, isn't it? So most likely the new data, the forecast should be less than the most recent one. It should be less. Therefore, this one will not be give you an accurate one. It will not be able to capture the change into the seasonality. Again, if you take the weighted moving average, what can you do? You are saying that this period could be closer to this period. Okay, I'll give more weight to this one. Therefore, your average will be very close to this period, okay? But still, you know, this value which is closer to this third value is still not the same as this one, because this one could be, you know, this could be like 98, but your new one, according to your data, it shows that demand now is going down. Therefore, most likely there will still be maybe around 93. So still, when you take the average techniques, will always they will give you now, a number that is still, you know, doesn't capture the new trend or the new seasonality. It will always be what we call it. It lags behind. There's always a time lag between the actual pattern and the forecast. Okay, and therefore, when you draw it, it will always be, you know, your forecast. When you draw your forecast based on weighted moving average or based on moving average, it will be around this one. Okay, you see, the seasonality has only been captured at period, let's say 4, but your seasonality had started at period 2. It is late, okay, to capture the actual, you know, seasonality. It's always late. But it's quite better than moving average because you can't change the weights. Okay? In exponential smoothing, a weighted averaging method is based on the previous forecast plus a percentage of the forecast error. What does that mean? Simply, an exponential smoothing is the previous forecast plus a proportion of the error. So a feature of the exponential smoothing is that it tries to learn from its previous mistakes. Now, it has made some mistake in the previous one, AT minus 1 minus FT minus 1, that's an error. Now, what is trying to do in the new forecast, as if it's like trying to learn from its previous mistake by taking a proportion of its mistake and adding it to the previous forecast, that will result into the new forecast. So it's as if it's like it has like some type of a learning mechanism. Now, then you can select alpha. What would be the best alpha that will give you the most accurate forecast based on how much of the previous error you will be taking and you will accommodate into the new forecast. Okay, the selection of alpha is a bit arbitrary, but one way to select alpha, which is also as well, it could be applied to the weighted moving average, that you could take a small alpha like 0.2, you take a medium alpha like 0.5, you take a large alpha like 0.9, and you apply each one of those exponential smoothing. You calculate MAD, for example, and you select the best one that will fit to your data. Now, you take the best of this one and you compare it to the weighted moving average, to the moving average, to the other ones, and then you select the best out of the best of all of those ones. Yes, the selection of the weights is arbitrary, the selection of the smoothing constant is arbitrary, but you can actually apply different methods. You can even, you know, use Excel or use some other optimization softwares to give you the most optimal value that will minimize your forecasting error. Okay, so that's the feature with the exponential smoothing, is that it learns from its previous mistake. But we should be aware that, you know, this exponential smoothing is only the basic one. You know, as I told you, that although exponential smoothing is classified as an averaging technique, like, you know, moving average and weighted moving average, but in fact, exponential smoothing is from a different family. As you can see, the formula of it is different. In fact, we have something called exponential smoothing, the basic one that we're applying in here. We have exponential smoothing with trend, and we have exponential smoothing with seasonality, and we have exponential smoothing with trend and seasonality. Okay, if you have seasonality in your data, then you most likely the exponential smoothing with seasonality would give you excellent results. If you have trend and seasonality in your data, then most likely exponential smoothing with the trend and seasonality will give you excellent results, best than all of the other techniques. Okay, but in here we're just taking the basic one. You could take other methods in other courses. That's the end of it for our presentation today. Thank you so much.